In problem 7, we are given this function 2x times the root of x minus 4. They want us to use a graphing utility to graph the function and then approximate open intervals where it's increasing, decreasing, or constant. So here's my graph. I got that on Desmos, desmos.com/calculator. And we want to know where is that increasing, open intervals where it's increasing. So increasing is up from left to right. So this portion of the graph is increasing and then keeps going. And that starts at an x value of -2. So that would be -2 to infinity. Decreasing down from left to right. So that's this portion of the graph is decreasing. That's from -3 to -2. So -3 to -2. And then constant is horizontal left to right, and there's no constant portions here. So that one does not exist. Next up, determine whether the function is even, odd, or neither. So even functions have y-axis symmetry. And notice that we do not have, here's our y-axis. And here's our x. We do not have y-axis symmetry. So no y-axis symmetry. So that tells us it's not even. So that's how you can do it from the graph. And then odd functions have origin symmetry, and this does not have origin symmetry either. Otherwise, we would see something like this. And that would look like origin symmetry. But we don't have that, so no origin symmetry. So that tells us that it is not odd. So together, neither. So this one is neither. And then remember the other test, if you don't look at it graphically, even here means that f of x is the same thing as f of -x. And odd means that f of -x, instead of being f of x, is the negative of f of x, which is equivalent to origin symmetry. So this is algebraically, and then these are the graphical ways to show even or odd. And then they want us to know, well, what is relative minimum? So that's a low point, bottom of the valley, which would be right here. So x comma y, x is -2, y is -4. So that is -2 comma -4. And then relative max, that one does not exist. Because this just keeps on going up. And then part C, approximate any relative min-max. Okay, that was our part C. So we're done. Now remember, if it doesn't end up here with whole number coordinates, that if you graph this in Desmos, you can hover your cursor over the min point or the zeros here, and it will approximate that to 3 decimal places.